طيب بسم الله الرحمن الرحيم. We started to talk about the GSM, second generation wireless. We talked about the main characteristics of GSM and how it was revolutionary at that time. It was connection oriented, using circuit switching, and the most importantly, it supports handover. And we will talk today about the main functionality in the different layers, how the channels are divided in GSM, and what is the main functionality for handover in particular. Assignment 3 also will focus on handover in GSM. So this is a split of functionality for between the BTS and the BSC. We said that BTS is the base station transceiver, and the BSC is the base station controller. And we said that one base station controller covers a geographical area that contains one or more base station transceivers. So usually each cell is managed by one BTS, and then the BSC controls multiple of these cells, providing some management, radio resource management, and high layer functionality between BTSs. And more importantly, of course, handles the handover between BTSs. So as a split of functionality, here we talk about the management of radio channels. The management of the radio channels usually is done by the BSC. Why? Because as we said that we have multiple channels, and if we assign all these channels to all the cells, then we're going to have interference, of course, right? So if the same frequency range is assigned to two cells, then there is interference. So we have to split the frequency range, and we split the frequency range based on channels. So our spectrum is divided into channels, right? So on average, GSM supports 10 channels per cell, right? So you have 10 channels per cell. So you can use these 10 channels for another cell with the condition that it's too far. So you can use special diversity. You can use the same frequency range, given that it's used by another base station which is too far, so you don't have any kind of interference, okay? But within neighboring base stations, you have to split the channels, and usually GSM splits the channels into, on average, 10 channels per cell. Why we say on average? Because we can use cell breathing at some point to, again, widen the range or shrink the range based on the density of users, right? So we can use cell breathing to increase the number of cells in one, the number of channels in one cell, and reduce the number of channels in another cell to accommodate different density of users. واضح كده? So because you have to manage the inter-cell assignment of these channels, it's done by the base station controller. Okay, usually this is done by the base station controller, and of course it's controlled also by the MSC, as we will see. Type frequency hopping. Where do we use frequency hopping here? Frequency hopping is used within the same cell by the mobile stations in order to mitigate the interference. In other words, as we said before, interference is frequency selective, right? So some ranges of frequency, they suffer from interference more than the others. صح كده? We talked about this before. So if one mobile station and one base station, they say they use the same channel over and over again, then they might have a big advantage or disadvantage, depending on the level of interference in that frequency range. واضح? So in order to make it fair, we have to use like also random assignment of the channel. We have to use some randomness in assigning specific channel to a specific mobile station at any point of time. Okay, so this is called frequency hopping. So the same mobile station, it hops from one channel to another, and usually that happens every around 5 milliseconds. We'll talk about this. So a mobile station may be allowed to use different channels every 5 milliseconds. So every 5 milliseconds it may hop from one channel to another. So this hopping ensures that it takes fair share of the interference. واضح كده؟ So the interference, if it affects a certain frequency range but not the other, then this mobile station will take like fair share of this interference. This is like interference equalization, if you will. Okay, type. Frequency hopping is actually managed by the base station. So the base station sends some signaling to the mobile station to allow the mobile station to select another channel every super frame. Super frame duration is around 5 milliseconds. We'll talk about this. But actually, in order to make sure that the new channel is not going to collide with another channel between the base stations, so it's also managed by the base station controller. So frequency hopping is one of the functionality that's managed by both, actually. Controlled by both. واضح كده? So we call frequency hopping for the mobile station, okay? Sometimes they call this as one of the types of handover. Although you're not moving from one base station to another, but you're moving from one channel to another. They also call this a handover. So this is a special type of handover called the intra-cell handover. Intra-cell. When you say intra, this means it's within the same cell, right? So there is handover between the same cell, right? Because you have an overhead. Switching from one channel to another does not happen in zero time. It takes about a few microseconds to switch from one channel to another. So there is some kind of overhead. So this is called a intra-cell handover. Okay? So frequency hopping is intra-cell handover. ماشي؟ واضح؟ متابعين؟ تفضل.
The handover between one base station to another done by the
base station controller, for sure, or the MSC. There are multiple types of handover. We'll talk about this. There is intra-cell, there is inter-cell, there is inter-PSC, there is inter-MSC. Yeah, so there are 4 types of handover. Okay, all of them will be included in assignment 3. You will see that colors, visual, كل حاجة. ماشي. Management of terrestrial channels. By terrestrial channels, we mean the data channels in using the A interface and A base interface. Remember A base interface? This is the interface between the base station and the base station controller. We said that there is like A base interface, and that multiplexes multiple voice signals that are coming from multiple base stations, right? So this this A base interface, we call the channels, or the traffic in that case, we call it terrestrial channels, okay? So this terrestrial channels, for sure, is actually managed by the BSC, of course. So these terrestrial channels are managed in that case by the BSC. طبعا, when it comes back to physical layer functionality, you have channel coding and decoding. By channel coding here, we mean the redundant bits that we add with the traffic to add some error recovery or error correction mechanism, right? So that's done at the radio link using the base station. Also, the rate adaptation. The rate adaptation is also, rate adaptation معناها ان انا by assigning مثلا multiple channels to the same MS, this way I'm actually increasing the rate for a particular MS and reducing the rate for another MS. So that rate adaptation is also done by the base station. We see by encryption and decryption, we see that all security functionality is actually done in all levels. Base station controller, and also in the operational subsystem, as we will see later. For security, we have to use authentication, message authentication. We have to use encryption and decryption and all of this. And usually this is done at different levels. The base station controller, and also at the MSC level, and also at the operational subsystem. We'll talk about this. Paging. What is paging? Paging is actually the procedure that we use in order to try to find one mobile station in the network as a trigger from a code. So when you trigger the number, when you dial the number, right? So we want to search for the mobile station that you are trying to call, right? So usually that happens through a procedure. We'll talk about the timeline for the paging. And paging here is triggered by one mobile station to another. And this mobile station might be a landline, or it might be another cellular mobile station, wireless mobile station. So in all cases, I need to know the location of the mobile station that you are trying to call, right? So this mobile station is in general roaming in the network, or roaming in another network, or maybe in another country. So how can I find this mobile station? So this is the process of paging. So I have to go fetch the location of the target mobile station using the phone number, right? And then I have to do some security checks, and I have to page معناها broadcast some signals to the location, geographical location where I think this mobile station might be. Okay, by broadcast here I mean it broadcasts to base station controllers in this area and all the base stations in this area. So all the base stations, they have information about all the mobile stations currently connected, and this way we can find the mobile station. So that usually is done through some broadcast signaling that has to go in a geographical location. ماشي? So geographical location here might actually cover a big city. So believe it or not, this signal might actually be broadcast to all the base stations in a specific city in order to try to find that mobile station. Okay. Type uplink signal measurement is usually done by the base station. By uplink signal measurement, this is actually used to trigger handover. So these measurements, this type of uplink signal measurement, I need to measure the signal strength between the base station and each mobile station. Okay, why this is needed? This is needed for multiple things. Most importantly, handover. So where do I trigger handover? If the signal to a particular base station weakens and the signal from that mobile station to another base station increases, right? So there is an intersection point where I say, oh, okay, so now I have to perform handover. So these measurements, they are done by the base station, okay? But some reports of these measurements come from multiple base stations to the base station controller, okay? And the base station controller is the one that decides whether there should be some handover or not. واضح كده? We'll also see the details of this and where do we trigger the handover. So all bad types of traffic measurements at the terrestrial level, authentication, location registry, and location update, this is actually, this has to engage the base station controller. We'll talk about each one of these. Why? Because it has to go to the back end. It has to go to the core network. All of these functionalities, they have to go to the core network. Okay, and in the core network, we talked about mobile switch center, and we talked about the operational subsystem. We'll see in the architecture. If you remember last time, we talked about these components in GSM, right? So all of these functions, they have to go to the core network, and they go through the base station controller. Location registry here and location update. So when I perform the handover from one base station to another, and from one BSC to another, and from one mobile switch center to another, right? I have to maintain the new location of that MSC. Why? Because then through paging, I need to know where at least the location of the mobile station is, and then I can broadcast a paging signal to the base stations in this geographical area in order to find the mobile station. ماشي كده? Any questions so far? Of course, all of these functionalities, we'll go through them in more details later. So for the mobile station, we talked about we talked about the mobile station before, and we highlighted only the terminal equipment and the mobility, the mobile terminal. And we said that the mobile terminal performs all the radio functionality. So the mobile terminal is the component inside the mobile station. Mobile station هو السيل فون يعني أو يعني the wireless node. So this mobile terminal performs all the radio functionality. In which case it facilitates the measurement to the uplink channel. It performs the channel اللي هو frequency hopping and all of this. It negotiates this with the base station. So that's done by the mobile terminal. The terminal equipment here is the application layer. Okay, so SMS and group fax and all of these is done by the terminal equipment. So these are the two components that we talked about. And here we have what we call terminal adapter. Terminal adapter, you can think of it as the interface or the intermediate layer, اللي هي transport layer يعني. صح? Because this is the application. This is a network access layer, right? So this is the transport layer, more or less, right? And here you have the UM interface, which is the interface between the mobile station and the base station. Mobile station and the base station. This is the UM interface. We talked about this UM interface. The rate here is like 5 kilobits per second or something like this. Say 4 kilobits per second, something like this. And we said that if you multiplex multiple of these in the ABIS interface, we get around 64 kilobits per second. Okay, so this is the rate for the traffic rate for these interfaces. So these three components constitute the mobile station. In addition to this, we have the SIM card. The SIM card ده بقى اللي هو احنا عارفينه كلنا SIM card اللي هو subscriber identity module. This is where the personalization بقى. This SIM card maintains many identity numbers, not only the phone number. You have the phone number, you have the serial number for the phone, you have the serial number for the SIM, we'll talk about many of these identity numbers, and each one of them has certain functionality. ماشي? Some of them are temporary, some of them are permanent. So we cannot use, in a specific location, we cannot use permanent numbers because these permanent numbers in some cases might be confidential. So by moving the mobile station from one location to another, we may have to assign some temporary number while the mobile station is in this area. When it moves to another area, we assign another temporary number and so on. So there are lists of these identity numbers which we'll talk about. Type. We have the network and switching subsystem, اللي هو MSC. Network and switching subsystem here contains the MSC and all the location registers اللي هم home location register visitor location registers. Okay? The MSC is, as we said before, is like the brain of the entire system. This is the one that interfaces with many components. It interfaces with the location registers. It interfaces with another gateway to get to another network, maybe landline network or any other type of network. It actually performs the handover. Okay, so it has many functionalities. So it's like the brain of the entire system. This is the one that manages many things. So it includes switching, mobility management, and interconnection to other network, right? So interconnection with other network here, we mean the interworking function, which is like the bridging function to another landline network or ISDN. فاكرين المرة اللي فاتت اتكلمنا عن PSTN or ISDN or something like that. Any kind of another technology network, we need what we call interworking function, or IWF. This is part of the architecture. So if we need to connect to PSTN, landline, or ISDN, there is native support for GSM standards to provide connectivity to these types of networks, right? So this was in the past. For any other technology, like if we want to connect GSM to WiMAX network or to another, from 2G to 3G, something like that. Any kind of other technology, we need what we call interworking function, which is like a bridge that maps from the GSM to another type of network. So we need this interworking function. So the interworking function is connected to the mobile switch center. Okay, so it gets connected to the mobile switch. So now there are two types of location registers. These location registers, they store information about the mobile stations in the network. ماشي؟ طيب, what is the difference? Home location register is sort of the centralized database. Usually, there is only one home location register for the entire network. So you might have multiple MSCs. So you may have more than one MSC. Typically, a service provider would have 1, 2, 3 mobile MSCs. Okay? And usually all of them are connected to one home location register. This location register stores all the permanent and semi-permanent information about the mobile stations in the network. Okay, the permanent information like what? Like the serial number of the phone number itself, things like that. Okay, and the semi-permanent is the location area of that mobile station. The location area changes if the mobile station moves from one city to another. So I need to store the new location area for that mobile station also in the home location register, right? So it's a centralized database that hosts the permanent and semi-permanent information for all the mobile stations in the network. Okay. طيب, the visitor location register بقى is a local database per location area. Is هنا local database. So this is a centralized master database, whereas this one is a local database. So there is one visitor location area per one visitor location register per location area. واضح? So each location area has one visitor location register. Visitor location register بقى usually stores all the temporary information about the mobile station. Okay, including not only بقى the location area of the mobile phone, but all the temporary IDs. So from one location to another, I may have to assign a temporary ID for that mobile station in that particular location area, right? And also it has some information about the security keys or the temporary keys. If you have taken network security before, during authentication we have master keys, right? And from these master keys we derive all the temporary keys, right? So master keys are usually hosted by the home location register because these are semi-permanent. But the temporary keys are hosted in the visitor location register. While the mobile station exists in a particular area, then we host all the temporary identity, temporary keys, all of these are stored in the visitor location register. ماشي? Okay? طيب. So the mobile switch center, as we said, it performs all the switching functions, اللي هي handover, switch from one base station to another, or from one BSC to another, and so on. So management of the network resources. So if I need to assign resources from one base station to another, perform cell breathing or reassign the channels or do some frequency planning or something like this. This is also part of the mobile switch center. Also interworking function. Interworking function, if I need to connect to another network technology or another cellular network or landline or something like this, then I have to perform interworking function, which is like a bridge. And here we have the gateway MSC. So gateway MSC is connected to the MSC to perform or to map all the functionality from GSM to another network. واضح كده؟ طيب. And also it connects to the databases, اللي هي home location register, visitor location register, and we'll talk about another type of database later. طيب طبعا it performs the paging. As we said, the paging is performed by first and foremost, we have to go to the home location register. Home location register can give you the location area where the mobile station is. So after this, I have to connect to the mobile switch center in that particular area. And then the MSC will take it from there. Will handle all the control until I find the MSC, and then it coordinates the establishment of the link all the way between the MSC and the landline, or the MSC and another MSC, and so on. So this is also managed by the mobile switch center. We talked about this interface before, اللي هو SS7. We talked about many interfaces now. There is the UM interface, there is the ABIS interface, there is A interface, and there is SS7 interface. The SS7 interface is the interface between mobile switch center and the home location register and visitor location register. Location register اللي هي databases يعني. ماشي? So this is the interface between MSC and the databases. Location registration and forwarding of location information, as we said. So I need to مثلا fetch the location of the mobile station from a particular area, and then I have to send it to مثلا the visitor location register and so on. During the handover, I may have to change the location from one location to another. So I have to the MSC has to update the visitor location register with the new location and so on. So that happens through the اللي هو SS7 interface. Provision of new services. Sometimes when I actually perform call, one of the steps that I have to do is to make sure that first this mobile station is authorized to make the call. Maybe that mobile station does not have access to make phone calls, or maybe sometimes that mobile station does not have credit. So I have to also contact billing and make sure that mobile station has credit, right? Maybe that mobile station is actually stolen, so I have to also consult. Yani there are so many details that I have to check before establishing the call. And believe it or not, we have to do all these checks before we give you access to make a phone call. Security checks, billing checks, access restrictions, policies. We have to check many things until we accept the call. The support for application level services. Sometimes the mobile station has or does not have access to SMS, so we also have to check that. Billing information, lower credit, and so on. So all of these are checked يعني from the mobile switch center. So mobile switch center connects to operational subsystem to check the billing, connects to operational subsystem to check whether the mobile station has access, has authority to make phone call, has SMS access, has enough credit, and so on. This is all managed by the mobile switch center. That's why we say the mobile switch center is like the brain of the system. ماشي واضح كده؟ طيب, in the back end بقى we have the operation subsystem. Operation subsystem here enables the centralized operations and management and maintenance of the GSM subsystem. So we have three major components. We have authentication center. Authentication center here, from the name, of course, it performs the authentication for the mobile station. So a mobile station, when it connects to the network for the first time, it has to authenticate itself. Similar to any that we talked about network access security. So this is the authentication server for GSM. Okay, so a mobile station, when it connects, once you open the phone, right? So you have to wait some time until it connects to the network. So it actually performs the authentication procedure, right? So it has to send request all the way to the authentication center to authenticate itself. Authenticate بقى how? Using all the identity numbers اللي هي stored in the SIM card. Right? In the SIM card, it has to send some identity numbers some اللي هو not only بقى الفون نمبر طبعا it has to send some يعني some security numbers which is stored in the SIM card. It sends that all the way to the authentication center, and then the outcome of this authentication process is ايه؟ الناس اللي خدوا network security. Outcome of any authentication process is actually the master key. So mobile station fetches or يعني generates a master key. This master key is between the mobile station and the network. From this master key, I derive the temporary keys for all the other types of security functions, including message authentication, data transmission, signaling, everything. ماشي? So what I mean by this is that authentication is done once in the beginning, and the outcome is master key. From the master key, I generate all the temporary keys. So moving from one location area to another, or during performing the handover from one base station to another, I may have to change the temporary keys, right? So I change the temporary keys, and host or store all these temporary keys in the visitor location register, because these are temporary keys, right? The master key is stored where? ها؟ ايوه in home location register. برافو عليك. ده شخص متابع. ماشي كده؟ طيب, so all these authentication parameters used to authenticate the mobile terminals, and then I can perform encryption and decryption. There is طبعا security, as you can imagine, in all levels. We have network access security, we have data security or higher layer security, right? So network access security performs encryption and decryption between the mobile station and the base station. Okay, so this is network access security. Data security, I actually do encryption and decryption between the mobile station all the way to the back-end system, and actually to the other network as well. I have to perform encryption and decryption end to end. ماشي كده? It goes through the core network. ماشي كده؟ طيب, so authentication center is used for authentication, and we have equipment identity register. That's another database, even one extra database. This is mainly maintains what we call whitelist and blacklist. Yani if the mobile station is stolen or there is some restrictions of access on this mobile station or something, then we store it in a blacklist, so that when the mobile switch center tries to establish or manage call or manage paging or handover for a particular mobile station, it checks this if the mobile station has become in the list of blacklist. If the mobile station has become in the list of blacklist, then I stop everything and I reject the call or reject the handover and so on. Ready? And there is operational and maintenance center, and this is it performs different control capabilities, including traffic monitoring. So this is the one that maintains traffic policies. Traffic policies. يعني ايه traffic policies؟ يعني مثلا a mobile station now performs not only a voice call, it performs مثلا data transmission. In data transmission, if you have one channel, then on average you have, I don't know, like 4.6 kilobits per second. So what if a mobile station tries to send more than that? So if so the mobile station is granted access as long as it follows certain traffic policies and network policies. If a mobile station misbehaves or something like this, then it violates certain policies. Then I may have to move the mobile station to a blacklist or stop the access or something like this. So this is managed by what we call a operation and maintenance center. And also this also checks the billing. ماشي, what kind of plan do you have? So when you make a call, مثلا, what is the price for 1 minute for this call? Things like that. So if I do مثلا a call مثلا to international number, then the billing will be different from calling a local number and so on. So this is the one that maintains the billing and the pricing and so on and so on. واضح كده؟ Any questions so far? Lots of details, but يعني maybe this is the first time you learn about standards like this. طيب, when it comes back to to designing the uplink and the downlink frequency planning for GSM. GSM, we have actually mentioned that before. GSM uses 124 channels for uplink and 124 channels for downlink. This slide here highlights the GSM 900 because it works here in 900 megahertz. So this is what we call GSM 900. So GSM 900 uses a subcarrier frequency or carrier frequency of 900 megahertz. So this is the downlink channels and this is the uplink channels. Not all of these channels are used for data, by the way, or voice. Yani. Not all of them are used for voice. In fact, only around 90 channels are used for voice and data. So what about the other 34? Used for what? For لا ما هو 90 are used for voice calls and data. And or أيوة for signaling بقى. Signaling and control and صح كده. So signaling and control is actually uses the other channels. طيب. So 124 channels. Each channel has a bandwidth of 200 kilohertz. By the way, 5G, the bandwidth is 20 megahertz per channel, right? So this is a 200 kilohertz. So the bandwidth per channel is 200 kilohertz. Okay. So 124, you have 124 channels uplink and 124 channels downlink. So one channel can be divided into in time bar, not in frequency, because as we have discussed before, GSM uses TDMA, FDMA, right? So each channel is divided in time into 8 slots. Okay. So in terms of time, you have 8 slots. 8 slots constitute what we call a super frame. A super frame. ماشي? A super frame is around 5 milliseconds, as we said before. Is around 5 milliseconds. اللي هي 4.6 something plus الجار bands اللي هم الناحيتين. Around 5 milliseconds. ماشي كده؟ So 8 time slots. Each cell, as we said, each cell gets assigned 10 of these channels. 10 of these 100 or 90 channels. يعني. 10 of these channels. So each cell has 10 channels, and each channel is divided in time in terms of super frame into 8 time slots, which means that in total, one cell can have, in 5 milliseconds, can have up to how many users, how many active users? 80, برافو عليك, yes. اللي هو 8 time slots times 10 channels. So on average, I can have up to 80 mobile stations active, right? Because there are some mobile stations, maybe they are connected to a base station, but they're not doing anything. I'm not doing any call, I'm not sending any data, so it's fine. I'm still connected to a base station and still authenticated, but I'm not doing anything. But I can have up to 80 mobile stations active at any point of time. What if I have more than that? Then you have to do channel allocation, and you decide. You decide which one takes resources at this point of time, which one can accommodate some delay. Maybe I cannot give you channel in this super frame. You have to wait for another 5 milliseconds in order to get a time slot in another super frame, and so on. This is about what we call radio resource management or channel allocation. واضح كده؟ طيب. So one time slot is around 577 microseconds. 577 microseconds. ماشي? So this is the frame. So this one is a super frame. ماشي? So this is the frame, which occupies one time slot. Okay? Type. This frame for one mobile station ماشي, has a specific format. So the format is guard spaces. We have guard spaces on left and right. These account for what? Account usually for propagation delay. ماشي? So these guard spaces, they account for propagation delay, because mobile stations, when they send a signal, this signal travels in the air, right? And it propagates through the air. So there is some propagation delay, right? So these guard spaces, they account for propagation delay. ماشي? These tail, they account for synchronization. We said that if you have multiple entities, they are trying to synchronize at a specific time slot, because these time slots are assigned to different mobile stations, right? So they have to synchronize themselves, right, in a specific time. Okay? But unfortunately, these mobile stations, they use different clocks. And these clocks have some clock drift. They may drift. If I ask you what time do you have on your watch and what time do I have on my watch, maybe there is like few microseconds different. Even 1 microsecond different, right? So when we talk about TDMA, we said one of the biggest issues in TDMA هو ايه? Synchronization. So we use these tail parts to account for the synchronization. Usually these tail bits is like they usually have many changes like this. Okay? So these changes, they are used to adjust the clock. So we call it self-synchronization. So the data themselves, they are used to facilitate the synchronization. We call it self-synchronization. ماشي? And these are used by the tail. Okay? So there is by the training. We call this training sequence or training bits. All of these are non-data bits, right? The tail and the training sequence, these are non-data bits. This is not data, right? These are control bits that are used for specific functionality. We said the tail bits are used for synchronization. The training sequence is used for channel estimation. Channel estimation معناه ايه? So this is used for channel estimation. Channel estimation معناه ايه? When I send the data to the base station needs to know what is the state of the channel for this mobile station. Okay? What is the state? اللي هي منها مثلا how much noise. ماشي? What does the channel look like? What is the signal to noise ratio? Things like that. So we use this to calculate the signal to noise ratio. We use this to facilitate the handover. We use this in many things. Okay? So we have to estimate the channel condition for a particular MS. And this is what we call the training sequence. So this is used for channel estimation. And in many cases, it's also used for synchronization برضه. So this training sequence has two functionality. Synchronization, in addition to the tail bits, and channel estimation. So for channel estimation, we use pilot signal or training sequence. And here, GSM uses training sequence. ماشي? So these are specific training sequence or specific bits that is agreed upon between the mobile station and the base station. By sending these bits, ماشي, the base station can check the signal, and based on that, it knows how much attenuation the signal suffers, how much errors, if there is too much noise. These training bits are supposed to be مثلا 1001, whereas I received 1110 مثلا. So there is high probability of error for this mobile station at this point of time, things like that. So I need to estimate how good the channel is between the base station and the mobile station. And that's very important for many functionalities. As we said, one of them is handover. ماشي كده؟ طيب. So these are control bits. Another control bit is called the signal indicator. So this signal indicator indicates whether this data frame or this user data, is it actually data or control? Is it like a voice data يعني, or a control data? So if it's 1, this is a user data. If it's 0, this is a control data. Something like that, but that's it. واضح? So this is one frame for one mobile station for one time slot in the super frame. So this is the format of the super frame and the frame per mobile station. Any questions so far? أيوة أيوة اتفضلي. Yes, usually for channel estimation, the training sequence is recommended to be in the middle of the frame. This is a recommendation يعني. This is done, by the way, through يعني hundreds of empirical studies. Hundreds of empirical studies leads to this. يعني many people they use they try to design techniques for channel equalization, channel estimation, channel coding, propagation. They do certain measurements and so on and so forth, and all of this feeds into how you define the standard this way.
So the user data are duplicated or it's
لا, it's not duplicated. This is user data and this is another user data. But in one frame, I may have user data and or control data in one frame. ماشي? Which is defined by the signal indicator. The signal indicator defines whether this is actually a user data. User data means it's a voice data or it's a control data. It's non-voice data. ماشي؟ أيوة.
why did they design the frame to have like 8 slots and like is there a reasoning behind this?
هو زي ما قلت يعني هو يعني there are some empirical studies that leads to this. If you increase the number of slots for a very, very long time, then it reduces the amount of control you can have. Because as we said, you can, for example, perform frequency hopping after one super frame. مثلا, ماشي? So they say, okay, so if I increase the number of time slots مثلا to 200, then I perform less frequency hopping because I cannot hop from one frequency to another within the same super frame or inside the super frame. They don't do that, right? So you have to do it every super frame. So if I make it very, very long, this means the frequency hopping will be less. ماشي? If I make it very, very short, the frequency hopping can be more. And there might be some other factors and implications and stuff like that. So as I said, they perform tons of empirical studies until they say, okay, so what addresses the trade-off is when we make it like this. ماشي? And also they take into consideration some other factors like what is the typical channel condition, what is the, طبعا a factor here is like what kind of transmission power you use, what is the tower, the antennas, the things like that. And then from all of these measurements and empirical studies, they come up with this recommendation. ماشي? So there are reasons, we don't have to know these reasons, but there are some reasons. ماشي? But this actually, when you know the details of the standard, sometimes it's very good. Why? Because sometimes you come up with very strong piece of work, right? And then you publish a journal paper, and then the reviewer would say, come on, this does not align with the standard. How come you are doing this work and it has nothing to do with the standard? ماشي? So when you design a particular technique, taking into consideration the standard details is totally different. Because then you can add مثلا some part of the work and say, okay, so I design a technique مثلا for radio resource management, and by the way, this aligns perfectly with the standard because in GSM we do this, we do that, and the technique that I'm designing here aligns perfectly with the standard. This adds another big value, significant value to your work. Because sometimes you come up with very, very strong work, but it conflicts with the standard. It cannot be implemented in any standard that that exists nowadays. كده كأنك يعني بتعمل شغل في المريخ، يعني انت يعني you are working on your own in silo and you're not taking into consideration all the what the يعني commercial companies and they come up with. ماشي. But when you say that my technique aligns perfectly with the standard, it has very significant value. واضح كده؟ طبعا you might think that GSM is actually old standard, but as we will see later, many of these concepts and architecture components have been maintained later on in 3G and 4G and 5G. It's just that parameters are different. And instead of مثلا 4.6 kilobits per second, we see nowadays we have 1 gigabits per second مثلا per channel مثلا. And instead of مثلا 200 kilohertz, nowadays we have more than 20 megahertz bandwidth. ماشي? And so on. But many of these components, they are maintained more or less. Even in Open RAN مثلا, we have nowadays, they are talking about Open RAN. ماشي? Open RAN has been يعني gaining a lot of يعني attraction from many research communities and even industry communities. Open RAN is said to be like a revolutionary thing for cellular networks, right? And when you see the ORU and ODU, and ORU is actually PTS, and ODU is actually BSC. Same thing, يعني. There is one-to-one relationship. It's just that different terminology, but you will see lots of functionalities, they are still there. But of course, the traffic rates, the bandwidths, parameters in general, they are much more, right? طيب, in terms of layer stack, the layered stack, so we have, as we said, we have the mobile station, base station controller, and MSC. So when we talk about end-to-end, as we notice here, the mobile station and the MSC, they have all the layered stack from radio all the way to the call management and mobility management, which is like higher layer functionality, right? So these higher layer functionality do not exist in the base station and the base station controller, because these are not engaged when it comes to call management. Call management here talks about the paging. Mobility management here talks about when you move from one location area to another, right? This is different from handover. This is triggered when you have a special type of handover when you move from one location area to another, which is what we call MSC handover. ماشي? So this type of higher layer functionality is only done at the MSC level and the mobile station level and the MSC. طيب. This is the radio resource layer. A radio resource layer, of course, is you can think of it as above the data link layer. ماشي? So radio resource layer interacts with the base station and the base station controller as well, right? And you have link adaptation. Link adaptation layer here, you can think of it as the data link layer. Data link layer here performs reliability, flow control, and so on. Layer part of the data link layer. And you have the radio. Radio here is the physical layer بقى. Lower channel coding, بقى channel estimation, modulation. ماشي? So these are the lower layers. So base station has up to the radio resource, which is, you can think of it as network layer or above the data link layer. Okay? One more difference here is that the physical layer from the base station to the base station controller is what we call PSM. PSM stands for what, حد عارف؟ اللي هو pulse code modulation. Pulse code modulation here, remember, between the BTS and the base station controller is wired. So this is the only wireless part. We know that, of course, from mobile station to the base station, this is the only wireless part. Okay? From base station to base station controller, from base station controller to the MSC to the operational subsystem and so on, this is all wired. These are all بقى servers infrastructure wires. تمام? So From the base station to the base station controller, we have what we call pulse code modulation. Pulse code modulation is a very primitive physical layer that is very good for voice, for physical layer, for voice. Okay? Pulse code modulation here talks about the fact that voice is actually is like a signal, analog signal. صح? Pulse code modulation talks about the fact that you actually sample these, and then you take each sample, you convert it to bits, digital bits, and then the digital bits would be transferred over the wired line. That's it. ماشي؟ there's no بقى يعني ولا بقى channel coding ولا يعني it's very very primitive, very introductory, very simple. ماشي? And this is designed for GSM because of the fact that here it's voice. We know that we are dealing with voice. طبعا PCM is not really efficient for مثلا data traffic or some other non-voice traffic. ماشي? But in any case, for GSM, because we're dealing mainly with voice signal, pulse code modulation is good enough. تمام كده؟ So from MSC to the base station controller and to the back end as well, we have what we call the SS7 interface. ماشي؟ So from here to here, it's wired. From here to here, it's wired. So the only difference is we go from 16 kilobits per second from base station to base station control. From here to here, we have like 4.6, I believe, something like that. So this switches to 16 to 64. So this is 64 kilobits per second. So this is the UM interface, ABIS interface, and the A interface. Okay, so from here to here, we multiplex multiple voice signals or voice data all at the same time from one component to another. So that's why the traffic rate gets higher and higher. Any questions so far? Lots of details, I'm sorry, but most of it يعني, I think is important. ماشي؟ طيب, we talk very quickly. Maybe يعني, we talk about this and then we stop. We talk about this topic. This is the paging. We talked about paging. So what is the signaling as part of the paging procedure? So this talks about making a phone call from one landline as part of the PSTN. PSTN اللي هي Public Switch Telephone Network اللي هي landlines. And we said that the support for PSTN in GSM is native. ماشي? So we have direct support to PSTN. And that was the situation in the past because it was very, very common to have landline. Of course, nowadays rarely we have landlines. So the support for this has almost is not part of the standard yet. But anyway, so we have a calling station, which is a landline phone, and then we dial the number of a mobile station. So we want to see what is the sequence of steps that we have to perform in order to establish this call from a calling station all the way to the mobile station. As you can see, there are about 17 different steps that we have to perform. So the first thing that we have to do is forwarding the call to the gateway MSC. Okay? We don't have interworking function here. Interworking function is needed if we're talking about a non-PSTN or non-ISDN network. So that's why here we don't have interworking. We don't have a bridge because the support for PSTN is native. So the call request, we have a call request. The call request goes through the gateway MSC. First and foremost, it goes to the home location register. As we said, this is a centralized database that stores permanent and semi-permanent information. In there, what do we expect to get? The location area of that mobile station. Location area refers to which MSC I need to contact to take that call further. Because each location area is controlled by one MSC, one mobile switch center. واضح? So in a big country, I may have 3, 4, 5 cities مثلا. Each city is covered by one MSC. ماشي? We call this a location area. Okay? So first, I need to go to the home location register. In the home location register, I fetch the location area. Then I know by this location area belongs to this MSC. So I send it to the MSC, خلاص. Then MSC will take it by from this point, will take it further.
Do it over the visitor.
Yeah, this is yeah, that's a very good point. Here we go to the home location register to fetch the location area. In some cases, in many cases, actually, we have to go also to the visitor location area of that particular, because we said that VLR is local database. The VLR is local database for a particular location area. From there, we get what? We get the temporary numbers and sometimes حتى temporary keys and things like that. ماشي? So here, request اللي هو mobile station registration number or something. This is a temporary ID. This is a temporary ID for that mobile station in this particular location area. ماشي? And then we go to the MSC, which is number 7. Number 7 here, forward call to MSC, and then the MSC will get the current status of the MS from, again, the location register. This this current status includes what? Includes, does this MS really have access or authority to make a voice call? Does this MS have enough credit to make this call? Okay, so that's also registered in the VLR. واضح كده? So this is what we mean here by get current status of MS. And then if I do all the checks and make sure that this mobile station has access to make this call, then the MSC will do paging. Paging, layer number 10 here, paging is broadcast signal to all the base stations in that particular area. Layer base station subsystem includes BSC and BTSs. So this location area is maintained by 2 BSCs and 10 base stations, right? So I have to send a broadcast paging signal to all these base station subsystems. All of them will have to send this paging to the mobile stations in this area until we find this poor MS that has to respond to this call. Okay, so when this MS responds, layer number 12 here, number 12, MS answers, ماشي? Then we respond back, and then before establishing here, we're supposed to establish the end-to-end. Before we establish the end-to-end, we have to do a security check. Security check here اللي هي do we have is this MS is really authenticated هنا اللي هو يعني if we need the accurate يعني this is message authentication, not device authentication. This is message authentication. ماشي? Is this MS authorized to make this call? The end-to-end authentication has been done, because this MS, if it does not actually authenticate itself to the network, it will not receive any paging أصلا. But this is what we call message authentication. So once we do that security check, we establish the link end-to-end between this calling station all the way to the MS. اللي هي بقى number 16 and 17. ماشي كده؟ So this is the sequence. The other way around that is very easy, because why? Because we don't have to do a broadcast. ماشي? From the cellular network, we know exactly that this MS is initiating the call. So the mobile station needs to make the call, initiate the call. In that case, we don't have to broadcast بقى خلاص. صح؟ Broadcast is done because it's all of us are connected wireless and we have to broadcast to get where this MS is, right? So when we do connection request, all we need to do is just to check security and check resources. That's it. Do we have enough resources to make this call? If the answer is yes, then we establish the call. That's it. واضح? But of course, it has to go through the MSC. Everything has to go through the MSC. ماشي كده? So this is a mobile station originated handover. And last thing اللي احنا اتكلمنا عليه, there are 4 types of handover. We have what we call, this is what we call intra-cell handover. Intra-cell معناها ايه؟ The mobile station is still in the same cell but it performs handover. This is what we call ايه بقى اللي احنا قلنا عليه؟ Frequency hopping. بالظبط. Okay, so we do frequency hopping. We call this intra-cell handover. And then from one base station to another, we call that inter-cell handover. Okay? This is to perform handover from one base station to another such that both base stations, they are maintained by the same base station controller. This is done when we do inter-cell and enter BSC. Enter BSC handover. When we move from one base station to another, such that one base station belongs to one base station controller and the other belongs to another base station controller. So in that case, we have to engage the MSC. Okay? ماشي كده? And the last one is enter MSC. This is about when you move back from one city to another. You are moving from one city to another. So in that case, both MSCs have to be engaged. واضح? So these are the 4 types of handover. Of course, each one of them, the delay associated is more. صح كده? To switch from to do frequency hopping is يعني microsecond level يعني. To do enter cell handover, we possibly need 1 millisecond, 2 milliseconds, something like that, because we have, not only do we have to switch the channel, but we have to switch resources as well. Right? We have to allocate resources in the new base station and remove the resources from the old base station. So that's another overhead. When we move from one base station to another, the overhead is more. When we move from one city to another, the overhead is more. So these are different levels which come with different levels of overhead. واضح كده؟ ماشي كده؟ Any questions? طيب, so when do we take the handover decision? The handover decision is based on, as we said, is based on some measurements. So the old base station and the new base station, both of them, they perform real-time measurements to all the mobile stations in the area, right? And they actually send, they coordinate these measurements with the mobile stations and in many cases with the BSC command. But to the BSC, we send some average reports every now and then. So these measurements, any kind of real-time measurements, by the way, they suffer from some inaccuracies or ups and downs. So we have to use some kind of a moving average filter or something like this. So as the mobile station moves from the range of one base station towards the range of another base station, typically what happens is that the signal strength to the old base station decays, and the signal strength to the new base station increases gradually. Okay? So the question here, when do we take the decision to perform handover? This is very important. Should we take it here or right after here? Okay? Yes or no?
No, we wait until the resource
لا 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 أنا هنا I'm talking about when to trigger the handover. When to trigger the handover. ماشي؟ برضه كل ده after triggering the handover. بس هو الفكرة في إيه؟ الفكرة since these measurements as you can see in real time they go up and down, and sometimes this is due to the noise floor or the noise on the channel, right? So to take the decision here or right after here usually is very bad. Why? Because this means that maybe the mobile station is moving, but it may actually go back, or it may stop. ماشي? So the problem here is that we get a very common effect called ping pong effect. يعني if the mobile station decides to stay مثلا in this location, okay, what will happen here is that the mobile station will suffer from ping pong effect because the measurements are going up and down. So you will find yourself that you're switching to this and then switching to this, and then so you keep switching back and forth. It's like ping pong. Okay? So usually we don't actually perform handover in this area. We don't do that. We have to wait until a specific margin called handover margin. After this handover margin, which means that definitely in this area, the measurements to the new base station is by far better than the old base station. So the decision here will be very mature and stable. Then and only then you trigger. When you trigger, you have to check. By the way, the fact that we trigger doesn't mean that the handover will be successful. Because again, similar to paging, there is huge sequence that you have to do before the handover is successful. ماشي؟ منها you have to do many security checks. You have to check many things. Do I have enough resources here or not? You have to check many things before you establish the link to the new base station. ماشي؟ But waiting for the handover margin allows you to avoid the ايه اللي هو سميناه ايه بقى؟ ping pong اللي هو switching back and forth. ماشي؟ واضح كده؟ طيب we can stop here to give so we'll have 5 minutes break and then we can start the progress presentations.